Good afternoon. Yeah. So just after lunch, so please be with me. Otherwise, after nice lunch, people will feel sleepy. But I think this topic is very interesting. And as we said in the initial session, the SDC focuses on evolving topics and things which are fluid or things which are moving. So you can't think of anything else which is so evolving and so much fluid as containers, right? How many of you have heard of containers? Everyone. How many have actually written some applications on containers? Okay, quite a few. So I think that's good in the sense that people have heard about containers and people know what containers are. And this being the storage conference now, our focus is on storage. So what is the storage story on containers? And that's what I'll be talking about. I'm not going to talk about any specific product or any specific company's work. This is more of an overview topic. I may not be able to go so much in depth given that we have only 40 minutes, but I'll try to give a good understanding about what the storage story for containers is, and especially we'll be talking about persistent storage. So fundamentally, I think containers became very popular. This technology has been there for quite some time, but with the advent of Docker about 5 to 6 years ago, containers became very popular. And what Docker did was they packaged containers in a nice form and created a standard around it. And now more and more people started using containers, and they realized that just as virtual machines and virtualization transform the whole computing industry by allowing us to make better usage of storage servers capacity, containers are even taking that virtualized story further. And the reason is that in a container, actually a lot less of the operating system gets distributed or replicated. So in that sense, fundamentally, if you can run, say, 10 virtual machines on a server, with containers, maybe you can run 30 or 40 containers because, it's a more efficient way of running multiple applications. At the same time, they give you most of the isolation advantages of virtual machines. So that way, it's a good compromise. But initially, when the containers thing started, most of the container applications were kind of ephemeral, what we call as ephemeral applications, or applications which don't store any persistent storage, which just do some compute, right? But over a period of time, as people realize that containers are very good, people try to migrate their existing applications onto containers, and many of those existing applications required persistent storage, in the sense they were doing something, but at the end they had to store something onto long-term storage. But when they try to do that, they realize that there is a shortcoming in the platform. So how that story evolved and how that gap with storage on persistent storage on containers, how that is being solved is what we'll see. Right? So fundamentally, what we are looking at is how containers have become popular and how the persistent storage for containers problem is being solved. Fundamentally, when people look at the popularity of containers, still a lot of the business critical applications have not moved to containers. And the reason, perhaps the number one reason for that is there is no good solution on how to have persistent storage on containers. Like Docker has something, Kubernetes has something, and then Mesos has another way of doing things, and different companies or different vendors have tried to come up with their own solutions. The storage vendors themselves are not very clear how their storage will be used with containers. So in a way, the whole thing is in a flux, and so this is one of the major problems we have. Part of the reason is that as containers move from one node to another, the storage also has to move, right? And that story is not good, unless you use NFS and things like that, right? So that's one of the biggest problems. As apart from the fact that there is no standardization, this particular problem, as we know, containers are supposed to be scalable, and or applications using containers are supposed to be scalable, which means that as the demands for an application go, we spawn more containers, or sometimes your infrastructure is not good or not stable, the node may go down. When a node may go down, we may move the containers to some other node. But as we move that, right, what if the second node on which my app is running does not have access to the persistent storage? Then my application cannot run, right? So one simple way to solve this problem is if you use network storage or some kind of a cloud storage. Because if you use cloud storage, then in theory, it's available from all the nodes. Or if it is a network storage like NFS, then in theory it is available from all the nodes. But if you are using block storage, let's say, then it becomes difficult. So it's not very easy to write a persistent storage application for a containers if you are using block storage, right? Of course, people can take existing applications and they can rewrite it or migrate it or re-architect it to use network storage or cloud storage. But then at times, whoever has developed your application may be already gone, right? Or sometimes your application is so deeply entrenched with block storage that it's difficult to rewrite or re-architect that application. So instead, what we want is to come up with a good solution in a container environment where block storage can be used, right? And that's what I think is a big struggle going on. So to explain the problem, basically a container needs to be mobile in the sense that if you have a node running a container and if that node goes down, or let's say that node becomes heavily used or occupied, I should have the ability to move my container to another node, right? But when that happens, I mean, typically, let's say you're using Docker containers, and if that container is using some kind of persistent storage, say a Docker volume, right? The Docker volume that I'm using should automatically move to the other node, right? How does that happen? If I'm using a storage array, how do I tell my storage array to take my actual volume and now map it to the other node, right? So that kind of orchestration or automatic movement of data as the container moves, or the ability for the array to know when your orchestration has moved a container, that is one of the biggest problems, right? The other problem, of course, is that there is a plethora of standards, a plethora of orchestration engines in the container world. I mean, we started with Docker, then Kubernetes came and Mesos came, and a lot of these orchestration engines, people are actually struggling to figure out which is the best one or which is the likely one to be used, or different orchestration engines do things a bit differently. So one is the mobility and other is the lack of standardization. These are, I would say, some of the two major challenges that people are facing when using persistent storage with containers. So we will look at how different approaches have been used to solve these problems. So to start with Docker, because Docker was one of the first companies which, as I said, standardized containers, right? And initially Docker came with a concept of a volume plugin, right? By volume plugin, what I mean to say is some kind of a driver which you can write. So you could write a volume plugin for different kind of storage, and that volume plugin has the ability to actually create a volume and attach it to a container in the Docker environment. So some of the problem with Docker plugins, and we can see that similar problems are existing elsewhere also, is that this plugin is actually required on every node, right? And because the attaching a volume to a node is a kind of a local action on that node. And I mean, apart from the fact that Docker has come up with a plugin standard which has some basic functionality like a create a volume or attach a volume, a lot of extra functionality which typically we expect from storage array is not standardized by Docker. So they just left it open to the plugin to define some kind of a attribute value combination by which you can add more features. For example, if you want a thin volume or a thick volume or a volume on a flash or volume on hard disk and things like that. So those kind of parameters which an application may want to specify in order to choose a particular class of volume is not standardized in Docker. And so that's one of the problems with the Docker volume plugin, that this volume plugin spec is somewhat very preliminary, and as a result now there's lack of standardization. As containers move from one node to the other, a lot of the volumes can get orphaned. So people have seen that in the container world, you use volumes and then you forget to unuse those volumes. So those volumes will remain on your node and they'll become orphaned. And an orphaned volume is a problem because sometimes by mistake a wrong container can get a wrong volume, right? So these kind of issues are there. Of course, data management standard like snapshot, etc. People who have used, let's say, VMware tools, right, for virtualization. In VMware world, we are used to snapshots, clones, and a lot of data management features which are kind of expected. But those in the container world are still not available. So these are all the issues people have faced in the container world when using storage. Now, the other orchestration engine which became far more popular over a period of time is Kubernetes. So Kubernetes also came up with their own volume spec, right? And although Kubernetes volume plugins are somewhat more advanced than Docker in the sense that they allow you to, they have standardized a lot of the plugin specification by allowing you to specify attributes and parameters, etc. Kubernetes volume plugin in a way is a much better improvement over Docker's volume plugin, yet some of the other problems that we have faced in Docker volume plugin are still present in Kubernetes. And the other basic issue is the spec differs considerably from Docker volume plugin. So if you are a storage array team or storage vendor and you want to use your, make sure your storage is available in container world, you will have to, apart from all the existing integrations that you have done with, Windows, Linux, or VMware, etc., you will have to have an integration with Docker, and you will have to have an integration with Kubernetes. And if there is another orchestration engine, you will have to write all these plugins. So the work on part of the storage vendor becomes too big. Right? So to solve all these problems, and to come up with some kind of standardization, and to solve this issue of movement of containers, and to come up with a better standard in terms of data management, snapshot, etc. Over the last 4 or 5 years, a lot of companies have come up with different approaches in order to solve these problems. So let us look at some of them. So I'll talk about a few. This by no means is like an exhaustive list of all the companies which have worked in this area, but it just gives you an idea of what different people have tried. For example, Cluster HQ was one of the first companies which became very popular because almost the same time when Docker came in, Cluster HQ realized these problems and they came up with a solution called Flocker, right? It was very popular at some point of time. However, of late, it so happened that it really did not succeed and the company is closed. However, the Flocker engine or the technology which they had, they have made it open source. So even now, this first solution is available. The second company which, a representative company which has come up with a solution which is somewhat different is Portworx. So we'll look at that. There is another open source engine called Rexray. So we'll look at that. And CSI is a new standard which is evolving in this container space, where hopefully over a period of time, there will be a single standard for all the volume plugins between containers and storage arrays. So let's look at each one of these one by one. Okay. So this is the architecture of Cluster HQ or Flocker, right? What they did was, I mean, their focus was not so much on standardization, but more on solving the container mobility issue, or essentially give some kind of a clustering effect, right? So what they did was they deployed a common control service called Flocker control service, which kind of oversees the entire container infrastructure in your environment, right? And so, for example, if you are running a container on one node, right, and let's say you are using Docker, then they have a plugin called Flocker plugin, which kind of is the volume plugin for that container, right? However, the underlying storage array could be anything, and what they did was they wrote an array plugin as per their own standard. So essentially now, irrespective of what storage array you are using, you use only one volume plugin, which is the Flocker plugin. And as you know, containers spawns up and request for a volume, the request will go to this common control service. The common control service will first see whether the volume that a container is asking for is already being used by another node, right? And if so, then it will make sure that the previous node is no longer using that volume, otherwise there will be some conflicts, right? Also, the Flocker plugin is associated with another agent. The Flocker agent is kind of keeping track of container life cycle. A container may start or may stop and so on. So as a container stops, the Flocker agent is able to detect that condition and remove the volume. So that way they solve the problem of mobility, the volume container mobility, and they also solve the problem of volumes being orphaned or wrong volumes being available on the node. Even after a container dies, the container forgets to detach the volume, or some volume simply remain. So this was a very good solution, and initially a lot of people used this as one of the solutions in the container world. The different solution came from Portworx. So Portworx actually came up when not only Docker but even Kubernetes and Mesos were fairly popular orchestration engines. So what they did actually was came up with some kind of a virtualization solution, and in this virtualization solution they have decoupled the orchestration engine from the storage array, right? In the sense that irrespective of what orchestration engine you are using, you have to write only one driver, and that driver actually talks to this Portworx software defined storage layer. So they did some kind of a storage virtualization, and by virtualizing storage they are able to actually, for example, if you have a large volume, they can carve that into smaller pieces and give it to containers, right? They can give, so it's kind of a virtualization layer or volume virtualization, and by doing so they have added a lot of features into their software defined storage stack, like snapshots, replication, encryption, etc. So a lot of value added features have been added. Of course, the drawback of this is now the Portworx layer becomes part of your data path, right? So in the previous solution that we saw, the Flocker was purely a control path solution, in the sense that when the container is writing data to the array, there was no additional overhead associated with it. However, in this case, all I/O from the containers to the array goes through this layer, but because it is going through that layer, they are able to add a lot of these value added features. So essentially you could say that this solution solves the problem of non-availability of value added features like snapshots, encryption, by implementing it in software in a common layer. It also solves the problem of having multiple standards or multiple plugin standards, because Portworx is the only plugin that needs to be installed, and after that every storage array vendor doesn't have to write their own plugin for Kubernetes, Docker, etc. So if you use Portworx, it kind of takes care of all that. So it was a good, neat solution, and some people are still using it. Now, Simultaneously, there was another effort called Rexray. So, Rexray actually was started by EMC, right, as a open source software project called Code, right. So, there was a focus called Code within EMC to start a new open source solution. As part of the Code project, a lot of different solutions in open source were written. One of them was Rexray. The focus was Rexray was basically containers, and so what this team wanted to do was to come up with a good solution for persistent storage for containers. They also did something, I mean, they did not add anything in the data path. So, the Rexray framework, although it looks similar to Portworx in the sense that it's a common framework, it does not sit in the data path, but it kind of solves the problem of writing a single driver and then using it with any orchestration engine. Eventually, what happened was that, as more and more standardization efforts started, and this is around the same time that different orchestration engines or the teams working on orchestration like Docker, Kubernetes and Mesosphere started talking to each other saying, hey, this situation is not sustainable that every orchestration engine is coming up with their own standards. Why not we talk to each other and why not we come up with a common standard so that irrespective of which orchestration you are using, which array you are using, you have to write only one plugin. And that effort started, it was also partly initiated by the Rexray team. So, Rexray along with all orchestration engines came up with a new standard or new effort called container storage interface. Right. So, I'll talk a little bit about container storage interface. So, container storage interface, the idea somewhat was borrowed from container networking interface. So, in the container world, a new standard called CNI came up, container networking interface, that became very popular, and because that became popular, people said let's have similar thing for storage. So, they came up with a stand for container storage interface. This is actually managed by Cloud Native Computing Foundation. So, Cloud Native Computing Foundation is a new foundation which has been started. It is part of the Linux Foundation, and their goals, so CNCF's goal is to come up with some kind of standards or some kind of a common APIs or common technologies which will be used for all cloud native applications, essentially container world. One of the first projects which actually went inside CNCF was Kubernetes. So, Kubernetes started by Google and became fairly successful. More and more people started using it. Then Google contributed to CNCF. Now, CNCF, it's across the industry standard. It comes under the umbrella of Linux Foundation. So, it's a kind of a place where multiple vendors, multiple orchestration engines and multiple consumer or what you can say user companies can all come together and collaborate and come up with some standard, right. So, people realized that there is a need for standardization and they came up with this CSI. So, hopefully, I mean the promise of CSI is that you can write the plugin only once and then you can use it with any orchestration engine. So, that way the work gets reduced and you can focus your effort on writing just one plugin, but make it good rather than writing 10 different plugins. And the way it works is that basically in the container world there are two ways of using containers. One is in the master slave format, that is you have a master host and you have multiple nodes which are kind of slaves. The master is the one who is actually running an application and it's kind of orchestrating the whole application, and the nodes are the slaves. So, if a node dies, the other nodes will come up, and on those slaves you can run say hundreds or thousands of containers. So, in that master slave configuration, you will have to write two different plugins, one plugin for the controller and one plugin for the node, right. And there are times when people don't have that master slave configuration. It's called a headless architecture. Headless architecture where every node is the same. There is no separation between a master and a slave. In a headless architecture, you can, in the CSI world, you can write a combined plugin. And a plugin basically has three kinds of services: an identity service, a controller service, and a node service. So identity is to kind of have some kind of a namespace or a directory or global repository of what are the different volumes or volume types that you have. Controller service is to do some kind of a create, export kind of control operation. And a node service is the one which runs on every node, which actually performs the data transfer between a controller and the storage. So in a way now CSI, it's at a very preliminary level, and you may not hear much about it, but it's coming up slowly. For example, Kubernetes, the latest version, has support for CSI. Right? So presumably now, over a period of time, different orchestration engines, and Kubernetes kind of becoming one of the most popular ones. So once they take the lead, the others will follow. CSI hopefully will become popular, and with that, more and more people should be able to use, should be able to write plugins. So with that, I think a lot of storage vendors will also get an incentive to go and write a plugin for CSI, saying that that's just one thing I need to do, and I don't need to write multiple plugins. And hopefully this whole persistent storage problem for containers should get eased out or solved in the next 2 to 3 years. That's the hope. So this is just a recall of how things have happened over a period of time. This whole thing has happened over the period of last 5 years. So it was only in 2013 or so that Docker came up with their first release, and within a year or so of that, Kubernetes came up with their first release. And so CSI actually was released late last year, early this year, right? So this story is still evolving. And I talked about Flocker port, Portworx, Rexray, and all that. So all this stuff has happened in the interim. Right? Now, what is the future, or what more is needed? So as I said, this still does not, so even the CSI spec does not take off advanced features like snapshots, replication, high availability, and so on. So these things are needed, because if you are running an application or trying to port an existing application, let's say from virtual machines or virtual apps to containers, then many of those applications will need high availability, because they are not written for the cloud world. Applications which are written for the cloud world actually have high availability built into them. But there are applications which are legacy applications which are not written with the cloud in mind. They need high availability from the underlying infrastructure, because the high availability is not fully part of the application itself. So dedupe, compression, snapshots, clones, encryption, these are all the high advanced features from the platform people expect. That is still lacking in the controller, in the container world. And many of these stateful applications will need in order to migrate to containers. But hopefully in the next 4 to 5 years, you can expect the container world to become more advanced and will have all these things. Okay. So a little bit of word about what my company, so I am from Dell EMC, right? And what we are doing in this field. So basically, as I said, the whole Rexray project, and even before that, when Cluster HQ came, we had a partnership with Cluster HQ. So that was the time when we actually worked very closely with them to write drivers for a lot of our arrays. So I was part of the Viper controller team, which has an open source version called Copperhead. So as part of Copperhead, we work with Cluster HQ, we work with Rexray, and we also came up with our own open source container solution. So the Rexray project, which was part of our company, has contributed quite a bit to the CSI spec. And likewise, some of our other divisions are also working on volume plugins. So all in all, we are fairly, involved in all this, and on multiple fronts we are working on it. So to summarize, I mean, I am more or less done. What different people we need to do, I mean, this is my take on what we need to do in order to advance this whole ecosystem further is, if you are part of any storage team, think about containers, and it's not enough just to say how to interface with operating systems, clusters, etc. How your storage works with containers becomes very important, because as more and more applications move to containers, you need to have a good solution for the container world. Everybody, I mean, just as SNIA is doing a lot of standardization work, the CNCF is doing a lot of standardization work in the container space. So we would request everyone to participate in CSI, participate in this Cloud Native Computing Foundation. If so, SNIA, I mean, as a standard body, I think should work with CNCF, and if CSI also becomes a SNIA standard, that will be a good thing. Application developers, if some of you are planning to write applications or planning to migrate your existing applications to containers world, be aware of this issue, and otherwise sometimes your stateful application, which works very good on virtual machines or on bare metal, may not work reliably on containers, primarily because of lack of state persistent storage on containers. Okay, so with that, this was the conclusion of an overview. So I realize that I didn't go into too much of depth into each of these, but I hope it has given you some picture about what's the state of the art as far as storage on containers is concerned. In case you have any questions, I would be happy to answer them.
Thank you very much for the detailed information.
Can you stand up? Yeah, thanks.
Okay. You want me to stand up?
No, it's okay. Yeah.
Okay. The one question I want to ask, like on the cluster queue Flocker, right?
Yeah.
So you mentioned that it provides a solution, but again, it is not in the control, meaning it is not in data path. So
yeah.
Which is, again, it is not going to eating your performance of storage. But what was the real problem? Still it is, meaning kind of lagged. So the whole standard is moving forward. Like, what was it missing there in Flocker?
Yeah, that's a good question. I mean, it was a very successful company and a very successful solution. Sometimes commercially it did not work out, and that's why the company closed down. Technology was good, but the problem was, again, multiple solutions came, right? Okay. And when multiple solutions came, the user community also gets confused. Oh, which one should I take? Should I take this or should I take that? And they go into a wait and watch mode. And once they go into wait and watch mode, then things can go wrong. So
it's about business problem rather than technical
problem. I think technically it was a good solution, but I don't think they could sustain it as a good business, and that's the reason it closed down.
Okay, thank you. The other question is, when you talk about data protection, deduplications, meaning encryption and all.
Correct.
So if I want to use a box from primary storage vendor or secondary storage.
Yeah.
So that comes with all these features inbuilt.
Correct.
If I'm building a plugin for those storage and provide that as a part of Docker, then I may not have those issues, right? Meaning, do we really need to, CSI need to care about providing those services as part of the plugin itself? Because it's going to come off the shelf of the CSI.
Array. Yeah, that's a good question. See, you're right in the sense that if your storage array has encryption or dedupe, why do I need it exposed at the application level?
Correct.
The thing is, you will, on a container world, you will be writing different kind of applications. Some may be for test and dev, some may be production, or some may be critical, right? So it would be good if in your container manifest, you are able to specify or what kind of storage you want. Maybe there are parts of your application for which you're okay with vanilla storage. There are parts of the application where you need encryption. So that end-to-end visibility for the application to specify what kind of storage it wants is useful. That's where a lot of the benefit comes in.
Okay. Okay. Thank you.
Yeah. We have only 5 minutes, so let's take only 1 or 2 questions.
I have a couple of questions.
Yeah.
So first one is, it is part from your call for action and partly from the previous question. So you mentioned that storage also needs to think about containers and try to optimize for that. So do you know any efforts going from storage vendors to try to differentiate or optimize, or is there any scope for optimization for containers?
Yeah, definitely. So as I talked about the CNCF, I talked about what Dell EMC is doing, a lot of storage vendors are doing. So if you look at Cloud Native Computing Foundation, many storage companies are part of it, right? So I think eventually as CSI becomes a standard, people, more and more storage companies will become part of it. Even today on Docker, a lot of storage companies are working closely with Docker, for instance. So yeah, I'm not saying that storage vendors are not thinking about containers. They are, right?
Okay, and another thing about standardization part. So we have other standards like OpenStack, which is kind of, even they had a separate stack for storage. And then again, there are some initiatives like Swordfish for storage management. So do you see there is any effort as such to consolidate all of this standardization and maybe come up with a common cause which actually incorporates the previous standards as well?
So OpenStack I would consider still as slightly, it's like a virtual machine technology, right? It's not container technology, right? So OpenStack, in OpenStack world, they use hypervisor, right? So it's more of a virtual machine technology. In OpenStack, you have Cinder as a standard, and there, a lot of these technologies are available. So yeah, I mean, there won't be a single solution, right? Some applications will work well in container, some will work well in virtual machines like OpenStack, some may work well on bare metal. So I think work is required in all directions. And coming to Swordfish, Swordfish is more at the array level. So I think that's a different domain altogether.
Hi, my question is, for container, the standardization has been done by Open Container Initiative Consortium. So they are standardizing how the container implementation and the image specification. So they are also specifying for volumes, and whether that will not fit here.
OCI, I'm not very sure, but presumably OCI and CNCF are working together, right?
I also have a question, but may I answer his question?
Yeah, go ahead. He's our next speaker. So the good thing is we are going to have a follow-up session, and he's also going to talk about storage for containers. I think a lot of the things will get covered there.
That's true. So yeah, OCI, I think Anil answered it very aptly. OCI was really at the Docker time, right? And CNCF has taken over the efforts, and it's leading mainly because of how Kubernetes is being adopted. And that's how Kubernetes and Mesosphere got together and started writing CSI. A lot of chronology that Anil has put very well. I should really give it for him. It's really evolving, and CSI you can consider as the last mile, and you can consider also as a replacement for Cinder, right? OpenStack is being replaced by Kubernetes, and Cinder is being replaced by, Cinder is nothing but a driver to connect to the vendors, right? So from OpenStack, and that's what CSI is being, I mean, it's already beta, and it's been used by many vendors. Kubernetes Mesosphere also has put it into beta. So yeah, OCI will remain, but CNCF is the standard initiative, and most of the open source technologies are coming. You can see, the TOC, the Technical Oversight Committee, is getting almost one new project every week or every month. that, no, take me there, take me there. Okay.
I won't say OpenStack is being replaced by Kubernetes or Cinder is being replaced by CSI, but it is kind of equivalent. You have Cinder in the OpenStack world, the equivalent on containers world is CSI.
That's true. I meant replace meaning
Yeah.
virtualization and containers.
Correct,
You can
correct.
say
It's analogous.
analogy.
It's analogous. Yeah.
OC is mainly the container interface, right? And this is how do you access from container, how do you access the storage interface, right? So you're defining the way to access the underlying storage. How do you provision a volume? How do you take a snapshot? And how do you set your dedupe attribute into the storage, right? So everything is moving towards developers, right? I mean, the entire containers is driven by how we develop the software, and the administrators are getting a second hand. Developers are becoming the key drivers, right? So that's where the DevOps industry is moving towards.
So friends, thanks a lot, but since we are running out of time, we can have more follow-up discussions. Thanks a lot for your attention.